Completing WeBWorK homework number 8. In this video, I'll demonstrate how to work the 5 problems in homework number 8. Keep in mind that your problems may involve different values, but the problems will be similar. In this problem, an article states that 45% of all Americans have brown eyes. That's the proportion of the population with brown eyes. If we take a random sample of 110 Americans, and find that 55 have brown eyes, determine the sample proportion. Determine the mean and standard deviation for sample proportions with samples of size 110. Determine the probability that in such a sample you observe more than 46.5% with brown eyes. In this problem, it suggests that 45% of the American population have brown eyes. If we consider a sample of size 110 and find that 55 out of the 110 have brown eyes, then this is our sample proportion. Our sample proportion is 55 out of 110, or 50%. If the population proportion is indeed 45%, then the expected value of the sample proportion, or in other words, the mean of these sample proportions, is also 45%. Also, for samples of this size, the standard deviation of the sample proportions may be computed using our formula P times 1 minus P divided by N. Here, 1 minus 45% is the 55%. Making this calculation, we find the standard deviation is about 0.047434. Here, the distribution of the sample proportions is centered at the mean value of 0.45. We're asked that for samples of this size, what's the likelihood that we find a sample proportion that's greater than 0.465? In other words, what's the likelihood we observe a sample proportion greater than 46.5%? Note that 46.5% is to the right of center. It's above average, and we're asked to find the portion of the distribution, or the area associated with this interval. Using our normal CDF command, we can make this calculation. For the interval with left endpoint at 0.465 and extending out to infinity, which we've called 10 to the 99th power, now specifying the mean of 45%, as well as the standard deviation we computed to be about 0.047434, we can make this calculation on our calculator. Make the calculation yourself. Do you get a value of about 0.3759? That is, the likelihood of finding a sample proportion greater than 46.5% is approximately 0.38. or 38% of such samples would have a sample proportion of this size, greater than 46.5%. That's the probability we're looking for, and that completes question number 1. If 53.3% of the population of eligible voters favor the incumbent, then for samples of size 490, determine the mean and standard deviation for the distribution of sample proportions. Based on this distribution, determine the probability that in such a sample, less than 49% say they will vote for the incumbent. In this problem, it is suggested that 53.3% of the population will favor the incumbent. We consider a sample size of 490 registered voters. For samples of this size, the expected value or mean of the sample proportions is given by the value of p, that is, the 53.3% of the population. The standard deviation for the distribution of sample proportions for samples of this size is given by taking the square root of p times 1 minus p divided by the sample size, in this case 490. Making this calculation, we find a standard deviation of about 0.022538. That is, we're considering a distribution that follows a normal distribution centered at about 53.3%. Next, we're asked to determine the likelihood that for a sample of this size, we observe a sample proportion of 49% or smaller. That is, what's the area associated with this interval, 49% and below? As we've done before, we can compute this area using our normal CDF command. Here the interval extends out to negative infinity, with the right endpoint at 0.49. The mean is 53.3%, and the standard deviation we've computed to be about 0.022538. Making this calculation, we find that the probability of a sample proportion less than 49% is equal to about 0.0282. That's the probability we were asked to compute, and that completes problem number 2. Suppose 62.3% of the population get relief from taking 2 aspirin. If we consider a sample of size 480, what is the mean and standard deviation for the distribution of sample proportions? For such a sample, what's the likelihood that the sample proportion is less than 58.2%? Use what you know about the distribution to compute this probability. In this problem, we're told that of the entire population, the percentage of individuals who get relief from 2 aspirins is about 62.3%. We're asked to consider taking a sample of size 480. Based on samples of this size, the expected value or mean of the sample proportions is that same 0.623. And the standard deviation for these sample proportions can be computed in the usual fashion, taking p times 1 minus p divided by the size of the sample. Computing this square root gives a standard deviation of about 0.02212. Here we have a normal distribution, a distribution of sample proportions that's centered at the mean of 62.3%. We're asked to consider the likelihood that for a sample of this size, we observe a sample proportion as small as 58.2%. What percentage of these samples have a sample proportion smaller than 58.2%? To compute this probability, to compute this area, we use our normal CDF command. Here, the interval we're considering extends from negative infinity up to 0.582, where the mean value is 0.623, and the standard deviation we computed to be about 0.02212. Making this calculation on our calculator, we find the value of 0.0319, or just over 3% of these samples. That is the probability or likelihood that one of these sample proportions is smaller than 58.2%. is approximately 3%. That's our probability. That completes problem 3. Suppose 62% of the entire population of amusement park visitors wait longer than 30 minutes for their ride. Consider a sample of size 60. What's the mean and standard deviation for the distribution of sample proportions? For a sample of this size, what sample proportion, p hat, is exceeded by only 18% of the sample proportions? That is, can you find a percentage such that only 18% of the samples have a higher proportion? For this population of amusement park visitors, it suggests that 62% of the population waits longer than 30 minutes to enter the ride. We're asked to consider a sample of size 60. Thus, the distribution of the sample proportions has a mean value of 0.62, and the standard deviation for these sample proportions is computed in the usual manner, multiplying p times 1 minus p divided by the sample size, in this case n equals 60. Making this calculation, we find the standard deviation is approximately 0.062663. For our distribution centered at 0.62, we're asked to find the proportion or percentage such that only 18% of such samples would have a proportion larger than this. That is, we're given the area of 0.18. So to find the location that cuts off that upper 18% of the sample distribution, we can, as we've seen before, use our inverse normal command. Recall the inverse normal command always asks us to enter the area to the left. And so in this case, cutting off the upper 18% of the distribution means we're left with another 82% to the left of this location. That is, the area to the left is the remaining 82%, where here the mean was computed to be 0.62, and the standard deviation for this distribution was about 0.062663. Making this calculation on our calculator, we find a proportion of about 0.6774. Thus, only 18% of these samples would have a sample proportion greater than about 67.74%. That's the proportion we were looking for, and that completes problem 4. If we assume this claim that of the population of male drivers, 77% will continue to drive even when lost, then for a random sample of 42 such male drivers, what's the probability that we observe a sample proportion less than 73%? We'll need to compute the mean and standard deviation for this distribution of sample proportions before we're ready to compute the probability. In this problem, it suggests that of all male drivers, 77% of this population continues driving even when lost, suggesting that we consider a sample of 42 of these male drivers. We're asked to determine the likelihood or the probability that in such a sample we observe a sample proportion less than 73%. To compute such a probability, we need to know about the distribution of these sample proportions. Can we compute the mean? Can we compute the standard deviation of these sample proportions for samples of size 42? Yes, we know the mean is given by the value of the population proportion, here suggesting 77%. The standard deviation can be computed based on that value of p as well, in addition to dividing by the size of the sample. dividing by 42 and taking this square root, we have a standard deviation of about 0.064936. Thus, for this distribution of sample proportions centered at 0.77, we can find the percentage of such samples that would have a sample proportion less than 73%. To compute that area, we'll use our normal CDF command, where the interval from negative infinity up to 0.73 is entered together with the mean and the standard deviation, that's 0.77, and 0.064936. Making this calculation, we find an area of about, well, just under 27%. Thus, our probability of observing a sample proportion less than 73% is approximately 26.9%. That's the probability we're asked to find. That completes problem number 5. Now it's your turn. Open up homework 8 under WeBWorK and complete your 5 problems.